first step towards achieving your dreams is having the right coach. Get the best education with Dr. Monica Jain and make your CBSE 10th, 11th and 12th dreams come true. Download the app now.
Hello students, very warm welcome to my YouTube channel once again. और कैसे हो आप? Hope everyone is fine. The today's topic for the video is isomers and isomerism. So we know very well this property of isomerism is a very important characteristics of all the organic compounds, and this topic is also very important for your exams also. It can be asked in various ways. So let me start this. So actually, what are the isomers and what is the isomerism? So I would like to explain it in a very simple way. So first we can understand about isomers. They are such compounds which contain exactly the same number of atoms, that is, they have exactly the same empirical formula, or we can say they have the same molecular formula, but differ from each other by the way in which atoms are arranged. So I can make you understand with the help of this example. So if we take the molecular formula, suppose is C8H10. So C8H10 means 8 number of carbon atoms and 10 number of hydrogen atoms are there. So this molecular formula can be written in these 4 various ways. So first way we can write it like this. So here first I have written ethyl benzene. So here benzene ring is there and having one C2H5 group. So if we calculate here, so we will find it is C8H10. So the next is the metacyrene, where benzene ring is there and 2 methyl groups are arranged on the meta position to each other. The next is the paraxylene. So here the 2 methyl groups are arranged on the para position, and the next is the orthoxylene, where the 2 methyl groups are arranged on the ortho position. So basically we can say these 4 are the isomers for the molecular formula C8H10. Means that if we calculate for all these 4 arrangements of molecules, so we will find all of them are having this molecular formula of C8H10. So means that they have the same empirical or same molecular formula, but they differ from each other by the way in which atoms are arranged. So here we can see all of them differ from each other only in the way the atoms are arranged. So this is in the one way we can understand. And second, we can say the isomers are such 2 or more compounds which have the same molecular formula but different chemical and physical properties are called isomers, and the phenomena is known as isomerism. So because we have seen here all of them are having the different arrangement of atoms. Now so they are totally different from each other. All 4 of them are different from each other, and they have thereby they have the different chemical and the physical properties. So all these 4 are called the isomers, and this entire phenomena is known as the isomerism. So I will make you understand in a very simple way about this isomerism by taking the example of alkanes. So as we know, the general formula for alkane is CnH2n plus 2. So if we write the first member of this family alkane, which is methane CH4. So there is, if I write it like this, and this is the expanded form. So in this way only this methane can be written, and there is no other way to write the methane molecule. So basically isomer and isomerism means ki how many various or different ways are there by which we can write the structure of any organic molecule. कितनी ऐसी possibilities हैं जिसमें हम उसके उस मॉलिक्यूल को हम रिप्रेजेंट कर सकते हैं. सो फॉर मीथेन ओनली वन वे इज देयर. So if we go to the next molecule, ethane, which is C2H6. So one way of writing is like this, CC, and each carbon is attached with the 3 hydrogen bonds. And this is the basically the expanded way. Expanded way when we are expanding all the carbon and carbon hydrogen bonds. Another way of writing is this condensed way. So here I have written like this, CH3 single bond CH3. So if we see this structure, so here suppose if we flip this molecule at 180 degree, so again there will be no change in the structure of molecule, it will remain same. So we can say there is no other possibility of writing this ethane molecule. So only one way it can be written like this. So let us now come to the next, propane C3H8. So I can write it like this, CH3, CH2, CH3. So I can write this like this also, CH3, CH2. Suppose this CH3 group, I write it like this, here CH3. One way is this to write, एक इस तरह से लिख सकते हैं, या another way is like this, कि ये हमने सेम रहने दिया, and this CH3 I am bringing it like this. So then let us see. So in these are the 3 various ways of writing the structure of C3H8. But here if we see, आपने like you have already learned about the IUPAC nomenclature. So suppose अगर हम इसके लिए IUPAC name लिखते हैं, तो what will be the name? It will be propane. Prop word root because 3 carbon atoms are there, and ane because all are the single bonds. So name, IUPAC name will be propane. So and in the IUPAC naming, what we have to do, we have to select the longest continuous chain. So if we write the name for this second one, so because longest continuous chain has to be selected, so in this case also this is the longest continuous chain. So again it will, the name for this will also be propane. And in this case if we see, this is also the longest continuous chain. So again in this case the IUPAC name will be propane. So basically all 3 are the same, because according to IUPAC naming all are having the same name of propane. So there is no difference between all 3 of them. So I can cut both these structures, so I can take only this one. So this, in case of propane, only one way of writing the structure is possible. So if we see, if we flip this molecule, so then this C1 will come this side, C3 will come this side, but again there will be no change in the structure of propane molecule as a whole. So it means this propane also has only one way of writing, means no other isomers are possible in the case of propane. So now I will come to the another example of butane. So what is butane? Butane is C4H10. So we can write all the possible ways or possible structures in the case of butane. So first is the simplest way. This is because 4 carbon atom chain is there. So this is the simplest way to write the butane. So this is butane, and according to the IUPAC name, and the general name for this is N-butane, because this is a straight chain. So this is the common name in this case. So the next possibility for writing this butane is, how can we write in the next possible way? This is the next possibility. So here I have taken the 3 carbon atom chain and 1 methyl group I have attached to this central carbon atom. So what will be the name, IUPAC name in this case? It will be, because parent chain is of 3 carbon atom, so it will be prop, and all are the single bonds propane, and this methyl group will be written as a prefix, and the position is 2-methyl. So this will be the name 2-methyl propane, and the common name in this case will be isopropane. This will be the common name, isopropane. And then what is there any another possibility to write this butane? Because in my knowledge, it can be written only in these 2 ways. There is no other possibility. Okay. So, and there is a general formula also by which we can understand how many isomers are possible in the case of any given molecular formula. So here, like the number of isomers is given by this general formula, and this is equals to 2 to the power n minus 4 plus 1, where n is the number of carbon atoms. Here n is the number of carbon atoms. So let us see in the case of butane how many number of isomers are possible. Butane is having 4 number of carbon atom. So n will be 4. 4 minus 4 plus 1 is equal to 2 raised to the power 0 plus 1. And this here we know very well, any number when raised to the power 0 is equals to 1. So the number of isomers in the case of butane will be 2. And these will be the 2 isomers in the case of butane. So I will explain it quickly once again. So in the case of butane, we know it is C4H10. So now we have to see in how many ways it can be written. So first is the simplest way. In a straight chain we can write it like this: 4 carbon atom chain, CH3, CH2, CH2, CH3. So this is having the IUPAC name butane, and the normal and the N-butane is written as the common name for this. And the next possibility by which we can write it, we can write as the 3 carbon atom parent chain and 1 carbon atom, 1 methyl group as the substituent on the central carbon atom. So name, IUPAC name in this case will be 2-methyl propane, and the common name is isopropane. This is the common name, and there is a one general formula by which we can know the number of isomers. So this is equals to 2 to the power n minus 4 plus 1, where this n is the number of carbon atoms. So in the case of butane, it will be 2 raised to the power 4 minus 4 plus 1 is equals to 2 raised to the power 0 plus 1, which is equals to 2. So in case of butane, there will be 2 isomers will be possible in this case. So this is how we can write here. So now I will discuss for the pentane. Okay, how many isomers we can write in the case of pentane. So what is the molecular formula for pentane? It is C5H12. So first let us calculate by the formula how many isomers will be there in this case. Number of isomers, this will be equal to 2 to the power n minus 4 plus 1. So n will be 5. So according to this formula, pentane should have 3 isomers. So now let us write what are the possibilities in the case of pentane. So first, in the same way, in a straight chain, we can write this. It is like 5 carbon atom chain is there, straight chain. So this is the simplest possibility in the case of pentane. And this is pentane. And the common name for this will be N-pentane, because it is a normal straight chain. This is the common name in this case. And then coming to the second possibility. Second possibility can be there 4 carbon parent chain we can write. We can write it like this: 4 carbon parent chain and 1 methyl group as a substituent. So if we write the Iupac name in this case, so it will be 2-methyl butane. This will be the name, and the common name for this is, isopentane. And the third way of writing this pentane is, here we have taken the 4 carbon atom parent chain. Now we can take the 3 carbon atom parent chain. And the 2 substituents are attached to the same carbon. So here we can see 3 carbon atom parent chain and 2 methyl groups on this second number of carbon atom. So the name in this case will be, Iupac name will be 2,2-dimethyl. 2,2-dimethyl, because 3 carbon atom parent chain, 2,2-dimethyl propane. And the common name in this case, when this type of arrangement is there, this is written as neopentane. This is the common name for this compound. So here we can see in all these three possibilities, three isomers, they are having the same molecular formula of C5H12. The only way they are differing from each other in the arrangement of the atoms in the molecules. Here it was the straight chain, here 4 carbon atom parent chain, 1 methyl group as a substituent. Here 3 carbon atom parent chain and 2 methyl group as a substituent. So in this way we can see that pentane has a 3 isomers. So it has the 3 isomers, and even by using this formula we can calculate the number of isomers without writing also. We can come to know about this. So thank you so much. Thank you. So in my next video I will covering this topic of isomerism in detail and cover all the topics which are there in the CBSE 11th class syllabus. So thank you so much.